Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So let's see what is given in a problem statement after try to apply some intuition in the problem statement. Okay. So we have given an integer n and we have to return the nth row of the following look and say pattern. Okay. So this is a medium level problem, but it's not an actually medium. It is a very easy level problem. So we have given a pattern. We have to print the nth row of that pattern. Now let's see what is given in a pattern. We have given a one, then one one two one one two one 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 two two one. Look and say pattern. Now what they explain this pattern to generate a member of the sequence from the previous member. Read off the digits of the previous member counting the number of digit in a groups of the same digit. For example, 1 is read as a 1 1. Okay, so next time this will become a next digit. 1 1 is a read of 2 1. Okay, so this is an 2 1, so this is an next one. 2 1 is read of 1 2, then 1 1, so it will become 1 2 and 1 1. Okay, now 1 1 2 1 2 2 1, this is will become third and so on. Okay, so this is an pattern and we have to generate the nth row of this pattern. Now how we will solve this problem, let's see. I will try to create a pattern by ourselves, and after that we'll try to make some intuitions. Okay, so this is an only one one, so I will count this one. How many one is this? Is an only one one. Okay, so can I say one one? So this will become a next row. It's one one. Now I will count the similar numbers. This is two one. Okay, so this is an two one for the next time. So it will become an two one. Okay. Now I will count a similar number. What is the similar? That one I have the occurrence. I will make a occurrence of the contiguous sequence. So here is an one two, and again here is an one one. Okay, now 1 2 and 1 1. Now I will calculate as occurrence. This is a single one, so I will say the 1 with a 1, then 1 with a 2, and then I have 2 1. It's a consecutively. Okay, so this will become 2 1. Nice. Now I'll just write it out. Now it will become 1 1 1 2 and 2 1. Nice. Now again I'll just calculate. I have the 3 1. Okay, then I'll just write a 3 1. Nice. Then 2 2 hai and 1 1. Okay, let's try to write it in next line like 3 1 2 2 and 1 1. Okay, okay, now if you just calculate that 1 3, then 1 2, sorry, 1 3, then 1 1, then 2 2, then 2 1, and you'll just write it out, so on. So by looking this pattern, what I'm saying, I'll just can't count. I'm just counting an contiguous sequence of the any previous row. So for that and from that previous row, now look at this. This is my previous row. This is my, if you are looking carefully, so this is my previous row. From the previous row I'll creating a next row, and for the next pattern it will become a previous. Okay, so this pattern is repeating. So and we have to generate an nth row. So for generating nth row, I, I need all n minus 1 row. I need all n minus 1 row. So I have to generate that n minus 1 row, so I can generate this nth row. This is another observation I am looking. Now I have to generate an n row. So suppose I have given an previous row, which is suppose this is an previous row. Like I'll just taking this is an previous row. So what is the previous row? Suppose this is an previous row. 1 1 2 2 and 1. So what I will do, I will just iterate on this row and I'll just calculate a contiguous similar sequence. Suppose this is a continuous 1, so I'll count the how many 1 come continuously. So in this example it is coming at 3 times. So I have count of 1 is equal to 3, count of 1 is equal to 3, and what is the character, what is the number is returning, this is a 1. Okay, so I will generate a next vector next as an array string. What is given in our example, I will generate this, and what I will add, I will add a 3 and 1. Okay, after that, by making a partition here, means I'll just calculate this to the similar. Now it's not a similar to this, so I'll make a partition here, and what I will do, I'll start counting this 2, how many times this 2 is repeating. So it repeating two times. So the count of 2 become a 2, and what is the number? It is an 2. So for next time, I'll just add it is 2 and 2 in my array or a string, and after that I'll just make a partition here. What is my next number? The next number is a 1. What is the frequency of 1? Which, how many time 1 is coming contiguous sequence? It coming only one time. Okay. So what I will do, I'll just add this 1 in my array. Okay. So what I will do, what I am doing, I'll just finding and previous. Now it will become my next for the next time. For the next pattern, it will become my previous, and I'll generate from the next. From here, look at this is in previous, and for the next I'll generate here. Now what I will do, I'll just try running this code again, so you will understand betterly. So I'll count my count, and frequency will remain the same. So what is the count? What is the number? It is 3. How many time it is occurring continuously? It is occurring once time. So I'll just add a 1 3 in my next array. So I'm adding a count first, and after that the number. Okay. Now next time is a 1 coming. What is the frequency of 1 in the contiguous sequence? What is the occurrence of a 1 in a continuous manner? That's 1. Only one time. So I'll add the 1 1. Okay. Now the next number is a 2. The next number is a 2. And how many means what is the continuous sequence of a 2? What is the length of the where the 2 is similar to the other numbers? So this occurred 2 times. So answer is a 2 2. Okay, for this that is a 2 1. Okay, and this generate my next pattern. Okay, and if you are just I'll making it previous for the next pattern. So I'm updating this array, previous array. I'll generating next pattern. For the next pattern, what I'm doing the same thing. Okay, so what I am saying, let's see what I am saying. Let's see what I am saying. I'll just write a function which will give me this output. Okay, this output means it will count and continuous sequence of a similar number and return that array or a string. Okay, and what I will doing in a main function which is given to us, the main function, what I will do, I'll write an for loop which go I to n. Okay, it goes to I to n, and that I'll just update the next s. So I'll create a function s, or I'll just taking a string. We have because we have given a string, so I'm just taking it as a string. We have to return a string s is equal to empty, or I'll generate a 1. Okay, after that the first previous sequence is a 1. Then I'll just starting I is equal to 1 to I less than n, and each time I will increase by 1. Okay, now in that s I'll generate a next s. For the next is what I'll do, I'll just calculate a continuous sequence. Now you know how to calculate a continuous sequence. If you don't, I will just code it out, and after that we'll try run again on that continuous sequence code, and we'll see the what is the time complexity out. So let's see. This is a very easy level pattern, so don't take too hard for it. If you want to understand, just do check 2 or 3 times. You can easily solve this problem. Okay. Let's see what I'm saying. I just can create an a next function, which will take an previous as a string. Okay, now what I'm saying, I'm just creating a string s with a 1, and I'll just go I is equal to 1 to I less than n and I plus plus. Okay, now for the s, I'll just do next of s, means it will update the next. Now in a next, I'll just take an one. What I'll do, I'll just take in a string. So this is next. I'll just add in the next sequence. Okay, so the function name will be the difference. Or I'll just take a string next is equal to empty string. Okay, now I'll just take integer I is equal to 0 and y I is equal less than previous dot size. Okay, now I'll just extract the character ch is equal to s of previous of I, and as I extracting the character, I'll increase the I plus plus. Now I'll take an integer count is equal to 1, and what I'm saying, while I is not less than previous dot size and similar to sh is equal to previous of I. If these two conditions satisfy, just increase the I plus plus and increase the count plus plus. Now when you are exiting from the loop, either it is an greater than, when you exit from this loop, what will happen? Either I is greater than the n, means the previous dot size, or you will change with the character. Suppose this is an 1 1, so this sequence will be changed, means this character is not matching with this 1. Okay, So either two these conditions. So what you have to do in a both condition, you have to just add an, what you have to do, you have to just add next plus and equal to, you just adding two string. Why I am just taking a two string as an count? Because there might be some chances in a later on I have a continuously more than 20 times 1 or 20 times 2 or 3 4, any of the number. So that's why I'm just taking in two string. Okay, and after that I have to just add which is the character is occurring multiple times. So instead of character I should take is a num, because this we discuss. So I'll just changing. Okay, now, okay, what I'll just do, I'll just return the next. Okay, now here I have to just return an s. Now let's try to compile it and let's try to submit it. If we get correct output, we'll just, okay, so yeah, it passes the example test cases. Let's try to submit it. Okay. Okay, so it gets successfully accepted. Now let's discuss what is the time complexity of this code. Before that, I'm just saying what is this is doing. So what this loop is doing, I just forget to say. So let's discuss. So in this, suppose I have a string 1 1 1 2 2 and 3. Okay. So what I'm doing, I extracting this character. What I'll just starting with the 0. I'm extracting this character and increase the size 1. Means I'm iterating from this to this string, and I'm just trying to match how many times this character is matching. Just increase the count. Okay, the count is the one because this is an one time, and what I'm doing, I'm just matching. You can go here to here, but what is the breaking condition? Until this character is matching with the other characters, so it will match, this one will match till here, and after that it will won't match. So my loop will stop when here. Okay, so I get and count is equal to 3, and what is my number is equal to 1. Okay, next time it started from here, next time my iteration will started from here, that time my number will be 2, and what happened, it will stop here. Okay, it will stop here. Suppose here also the 2, then it will stop here, out of the loop, out of the range. That condition is I is greater than previous dot size. So only this thing I'm doing. So in this loop, now what is the time complexity of this code? So let's see. By observing pattern, you will understand what is the time complexity. So if you are looking here clearly, so what is the length of this? The length of this is an 1. Then this is a 2. This is a 2. This is an 4. This is an 2 2 2 6. Okay. Now if we already generated the next pattern as well. So what is this length is 2 2 6. This is also the 6. Okay. Now this is a 6. If we are trying to generate the next pattern, what is the next pattern of this? So what is the length? 2, 2, 2, 2. So what is this? 8. Okay. So can I say that this is an just pattern which is an I starting from 0 to n, and the k, which is the vector length, is increasing 2 to power k. Can I say like 2 to power 1 plus 2 to power 2 plus 2 to power 3 plus 2 to power 4? It's not an increasing approximate. We can consider approximately 2 to power k, because it will goes, let's see, like it is increasing by 2. Like here it is increasing by 2, it is increasing by 2, it is increasing by 2, it is increasing by 2. Then after that it is increasing. So can I say it is approximately 2 to power n minus 1? Can I say 2 to power n? I'm not saying it's actually correctly it's an completely 2 to power n, but it is approximately 2 to power n. It will generate an 2 to power n. For the longest sequence you will understand it's like increasing like 1 2 2, then 4, then 6, then 6, then 8, then 10, then 14, then 16, then 20, so on. So if this is increasing, like this is an 2 to power 0, then 2 to power 1, 2 to power 2, then 2 to power 3, then 2 to power 4, something like this. Okay, so on. So can I say this goes to approximately 2 to power n minus 2 to power n? Okay, approximately it's going to the 2 to power n. So the time complexity will go to the 2 to power n. Why I'm saying? Because this loop, even this loop is going to do big of n time, but it is going to the 2 to power n. Okay, so it's actually the 2 to power n this time complexity. And what is the space complexity? And each time I'm storing the sequence of 2 to power n. So the space complexity also the 2 to power n. Okay, so time and space complexity both are 2 to power n. Okay, so this is for today's problem. If you have any doubt, you can ask in the comment section. And bye for today. Let's meet tomorrow with a new video.